Next is 20th question. This is a question from matrices. So given that the matrix A square 1 plus A cube, B square 1 plus B cube, and C square 1 plus C cube equals to 0. And we need to prove that ABC equals to minus 1. Applying the row operations, R1 implies R1 minus R2 and R2 implies R2 minus R3. So I'll get the matrix. So this is det of A minus B, A square minus B square, and here it is 1 plus A cube minus 1 plus B cube is A cube minus B cube, and the second row becomes B minus C, B square minus C square, this is B cube minus C cube, and the third row is C square 1 plus C cube, which is equals to A minus B. Here writing it as A minus B into A plus B. So I am writing A square minus B square as A minus B into A plus B, and A cube minus B cube as A minus B into A square plus AB plus B square. This is the formula of A cube minus B cube. And similarly B minus C into B plus C, and this is B minus C into B square plus BC plus C square, and the third row is as it is C square 1 plus C cube. Now in the first row, take out A minus B common, and in the second row B minus C is common. That equals to A minus B into B minus C into det of, this is 1 A plus B, and here A square plus AB plus B square, and here it is 1 B plus C, B square plus BC plus C square, and the third row is C square 1 plus C cube. Again applying the row operations, R1 implies R1 minus R2. I get A minus B into B minus C into det of 1 minus 1 is 0, and here A plus B minus B plus C, which is A minus C, and here I get A square minus B square, this is A square, and plus B square minus B square gets cancelled, so ultimately I get A square plus AB minus BC minus C square. These two terms gets cancelled, and the second row is 1 B plus C, B square plus BC plus C square, and the third is C square 1 plus C cube. That equals to, in the first row, this is A minus B into B minus C of 0 A minus C. In the first and the last term, I can take out A minus C is common. So A minus C into A plus C plus, here AB minus BC, taking out B common, B into A minus C. 1 B plus C, B square plus BC plus C square, and this is C square 1 plus C cube. That equals to, I can take out A minus C common here, so A minus B into B minus C into A minus C of det of 0 1, here I have A plus C plus B, and this is 1 B plus C, B square plus BC plus C square, C square 1 plus C cube. This entire thing is equals to 0. Now expanding the determinant, a minus b into b minus c into a minus c of, expanding this is 0 minus 1 into 1 plus c cube minus c into this, so this is b square c, and minus bc square minus c cube plus a plus b plus c into c square minus, so these two, let up these two, c square minus bc minus c square, which is equals to 0. That equals to a minus b into b minus c into a minus c of c cube plus c cube gets cancelled, and minus c square plus c square gets cancelled. So minus into everything becomes b square c plus b square c, and minus 1 into 1 is minus 1, plus this is a into minus bc, so we need to multiply minus bc for all these three terms. So minus abc minus b square c and minus bc square equals to 0, plus b square c minus b square c plus b square c, this is bc square, plus bc square minus bc square gets cancelled, and at last what I have is a minus b into b minus c into a minus c into minus 1 minus abc equals to 0. Since this part is not equals to 0, this part should be equals to 0. That implies minus 1 minus abc should be equals to 0 and abc should be equals to minus 1. This is the required proof. 21st question. Solve the system of equations using the Cramer's rule. So given x plus y plus z equals to 1, 2x plus 2y plus 3z equals to 6, and x plus 4y plus 9z equals to 3. These three are the given system of equations. Converting these equations into matrix form, I get the matrix 1 1 1 2 2 3 1 4 9 into xyz is a variable matrix. This is equals to 1 6 3. So this is of the form a into x equals to b, where my matrix A is this matrix of 3 by 3 and x is a variable matrix and b is this 3 by 1 matrix. By Cramer's rule, by Cramer's method, I can find the values of x, y, z, where x equals to delta 1 by delta and y equals to delta 2 by delta and z equals to delta 3 by delta. So to find x, y, z, I need to find the values of delta 1, delta 2, delta 3 and delta. Delta is the determinant of matrix A, which is equals to 1 1 1, and next is 2 2 3 and 1 4 9. This is equals to 1 into 9 into 2 is 18, 18 minus 12 minus 1 into 18 minus 3 plus 1 into 8 minus 2, that equals to 6 minus 15 plus 6, which is equals to minus 3. So delta equals to minus 3. Now let's find delta 1. Delta 1 is the determinant of the matrix A, but we need to replace the column 1 with this matrix. We need to replace the column 1 of this matrix with B matrix. Now it becomes 1 6 3 1 6 3, and the remaining matrix won't be changing, which is 1 2 4 139. That equals to, solving this, 1 into 18 minus 12 minus 1 into 54 minus 9 plus 1 into 12 minus 6. This is 24 minus 6. 6 into 4 is 24. That equals to 6 minus, this is 54 minus 9, which is minus 45, plus 24 minus 6 is 18. So minus 45 plus 24, which is equals to minus 21. So delta 1 equals to minus 21. That implies value of x equals to delta 1 by delta, which is equals to minus 21 by minus 3. That equals to 7. Delta 2 will be equals to determinant of matrix A, but this determinant is obtained by replacing the second column with the column matrix. I'll be getting 1 2 1. The second column is 1 6 3, and the third column is as it is 1 3 9. That equals to 1 into 6 into 9 is 54 minus 9 minus 1 into 18 minus 3 plus 1 into 6 minus 6. This will be 45 minus 15, which is equals to 30. So y will be equals to delta 2 by delta, that equals to 30 by minus 3, which is equals to minus 10. The value of y equals to minus 10. And the value of z we need to find now. Delta 3 will be equals to the matrix A obtained by replacing the column 3. So column 3 is this 1 2 1 1 2 4 1 2 1 1 2 4, and the column is 1 6 3. That equals to 1 into, this is 6 minus 24 minus 1 into 8 minus 2 plus 1 into, this is minus 1 into 6 minus 6 plus 1 into 8 minus 2. That equals to minus 18 plus 0 plus 6. That equals to minus 12. So value of z will be equals to minus 12 by minus 3. That equals to 4. The values of x, y, z equals to, this is 7 minus 10 and 4. So this is the required matrix. Next question is, find the volume of the tetrahedron whose vertices are given as, 4 vertices were given now. So I'm writing the position vectors. OA bar equals to I bar plus 2j bar plus k bar, and OB bar equals to 3I bar plus 2j bar plus 5k bar. OC bar equals to 2I bar minus j bar plus 0, and OD bar equals to minus I bar plus k bar. So I have 4 position vectors. AB bar will be equals to OB minus OA, that equals to, this is 2I bar plus 0 into j bar plus 4k bar, and AC bar equals to I bar minus 3j bar minus k bar, and AD bar equals to OD minus OA bar, that equals to minus 2I bar minus 2j bar plus k bar minus k bar is 0 bar. So these are the 3 vectors now. Whenever we have 3 vectors now, so these 3 vectors are representing the vectors of the tetrahedron in this way. So down we have a base with the triangle, and this is the tetrahedron. So this is A, B, C, D. So AB is one vector, AC is one vector, and AD is one vector. Now the volume of tetrahedron is given as volume equals to volume of tetrahedron is given as 1 by 6 of data of AB bar, AC bar and AD bar. We need to find the data of these three vectors. The three vectors are now AB bar equals to 204 and this is 1 minus 3 minus 1 and minus 2 minus 2 0. That equals to 1 by 6 of 2 into, this is 0 into 3 is 0, minus of plus 2 is, so it's minus 2 plus 0 plus 4 into minus 2 minus 6 minus 2 minus 6, so 1 by 6 of minus 4 minus, this is 8 into 4 is 32, that equals to 36 by 6. That equals to 6 units, 6 cubic units. So this is the volume of tetrahedron, 6 cubic units. So next is 23rd one. If ABC are the angles of a triangle, then prove that sin A plus sin B plus sin C equals to 4 cos A by 2 cos B by 2 cos C by 2. So 23rd is sin A plus sin B plus sin C. We know that sin C plus sin D equals to 2 sin C plus D by 2 into sin cos C minus D by 2. Sin C plus sin D equals to 2 sin C plus D by 2 into cos C minus D by 2. That equals to 2 sin of A plus B by 2 into cos of A minus B by 2 plus sin C. That equals to 2 sin of, I have A plus B plus C equals to 180 in a triangle. From this I can write that A plus B equals to 180 minus C and A plus B by 2 equals to 180 by 2 minus C by 2, that is 90 minus C by 2. 2 sin of 90 minus C by 2 into cos of A minus B by 2 plus sin C. That equals to, so this is 2 cos C by 2 into cos A minus B by 2 plus, I can write sin C as 2 sin C by 2 into cos C by 2. Taking out 2 cos C by 2 as common, these two terms are common here. I have cos of A minus B by 2 plus sin C by 2. Now convert the sin C by 2 in terms of cos. I can write that C by 2 equals to 180 minus A plus B by 2. So this is 90 minus of A plus B by 2. That equals to 2 cos C by 2 of cos of A minus B by 2 plus, this is sin of 90 minus A plus B by 2. That equals to 2 cos of C by 2 into cos of A minus B by 2 plus cos of A plus B by 2. Now we know that cos c plus cos d equals to, the formula is that 2 cos c plus d by 2 into cos c minus d by 2. So this is the formula for cos c plus cos d, that equals to 2 cos c by 2 into, so cos of c plus d, which is a minus b by 2 plus a plus b whole divided by 2 into cos of c minus d by 2. C is a minus b by 2 and minus of d is minus a minus b whole by 2. So this is 4 cos c by 2 into cos of b gets cancelled, a plus a is 2a by 2 is a, so overall get cos a by 2 into cos minus a plus a gets cancelled, I get minus b by 2, that equals to 4 cos a by 2, cos b by 2 and cos c by 2. So that equals to RHS. And the last question is that if R is to, capital R is to R1 is 2 is to 5 is to 12, then prove that the triangle is right angle triangle. So given that R is to, this is the 24th question, capital R is to R1 equals to 2 is to 5 is to 2 is to 5 is to 12 is given. We need to prove that the triangle is right angled at vertex A. If I take R1 minus R, so before this what we do is, let R equals to 2k and capital R equals to 5k and R1 equals to 12k. K is some constant here. So R1 minus R will be equals to 12k minus 5k. This is 2k, sorry. 12k minus 2k equals to 10k. That equals to 2 into 5k. I know that 5k equals to capital R, so this is 2r. I got R1 minus R equals to 2r. We know that R1 equals to 4 into R into sin A by 2 into cos B by 2 cos C by 2, and R equals to 4R sin A by 2 sin B by 2 and sin C by 2. So these are the values of R and R1 here. Substituting these values here, what I get is 4R sin A by 2 cos B by 2 cos C by 2 minus 4R sin A by 2 sin B by 2 and sin C by 2 equals to 2R. In this I can take out 4R sin A by 2 as common, so 4R sin A by 2 is common, so cos B by 2 into cos C by 2 minus sin B by 2 into sin C by 2 equals to 2R. 2R and 2R gets cancelled, so this is 2 into sin A by 2. This is cos A cos B minus sin A sin B, which is cos of A plus B, cos of B plus C by 2, that equals to 1. So sin of A by 2 into, I can write this as cos of 90 minus A by 2 equals to 1 by 2. Sin A by 2 into This is cos 90 minus theta, which is sin theta. Sin a by 2 equals to 1 by 2. Sin square a by 2 equals to 1 by 2, and sin a by 2 equals to 1 by root 2. That implies a by 2 equals to 45 degrees and a equals to 90 degrees. So my triangle is right angle triangle at vertex A.